Hello friends, welcome back to my channel Universal Analyzer. We will start the video by an inspiring quote. Don't carry your mistakes around with you. Instead, place them under your feet and use them as stepping stone to rise above them. In this video, we are going to solve the simultaneous equations with the help of the determinant method. This method is also called as the Cramer's rule. The scientist Cramer have been found this method, therefore it is named as a Cramer's rule. To use this method, that is the Cramer's method, we have to form the equation in the form such as a1x plus b1y is equal to c and a2x plus b2y is equal to, it will be c1 and it will be the c2. We know the general form of the linear equation in two variable as ax plus by plus c is equal to 0. As we know the general form of the linear equation in two variable as the ax plus by plus c is equal to 0. But to use this Cramer's rule, we have the constant term towards the right hand side. Now, these two are the general forms of the simultaneous equations. Here, determinant D will be equal to, in this we have to write A1, A2, B1, B2. Here A1, A2, B1 and B2 are the constants of these equations. A1, A2, B1, B2 in this way. Now, dx will be equal to, what we have to take in dx, which constants we have to consider is that c1, c2, b1, b2. Here d is there, means we have to close this and we have to write a1, a2, b1 and b2. Now here dx is there, x variable we have to close and consider this c1, c2, b1, b2, and they should be in this sequence. dy is equal to, y we have to close a1, a2, c1, c2, a1, a2, c1, c2. Now we will take one example to understand this Cramer's rule. First example, here there are two equations, that is called as simultaneous equation. We have to solve these equations with the method Cramer's method. Therefore, first of all, we have to observe that it is in the form of a1x plus b1y is equal to c or not. It is in the c because constants in both equations the constant are in the RHS side. Now, comparing these constants with this equation, here a1 is equal to 3, b1 is equal to -4 and c1 is equal to 10 and a2 is equal to 4, b2 is equal to 3 and c2 is equal to 5. If they are not, this constant term is not on the RHS, then we have to transfer it towards the RHS. Now, we know determinant D will be equal to, here it is A1, A2, B1, B2, which will be equal to, what is the value of A? It is 3, A2 is 4, B1 is -4 and B2 is 3, which will be equal to, we know how to solve this determinant, or how to find the value of this determinant. 3 into 3 minus 4 into 4 minus 4 into 4. First of all, we have to do in this way, and next we have minus this term multiplying this term, which will be equal to 3 into 3 is 9, minus 4 into 4 is minus 16, will be equal to 9 minus plus 16 will be equal to 25. Therefore, here the value of D will be equal to 25. Now, dx will be equal to, we know dx is c1, c2, b1, b2, which will be equal to, what is the value of c1? It is 10, c2 is 5, b1 is minus 4 and b2 is 3, which will be equal to 10 in, we have to multiply 10 into 3 minus 5 into minus 4. Here we should not consider this minus is different, and this minus consists of the to the 4. Therefore, the value is 10 into 3 is 30 minus 4 into 5 is minus 20, which will be equal to 30 minus plus 20, which will be equal to 50. Therefore, the value of dx will be equal to 50. Here we have to see that the sequence should be c1 by c2 and b1 b2. It should not be interchanged. Now we have found the value of d and dx. Now the value of dy will be equal to determinant of a1, a2, c1, c2. We know the value of a1 is 3, a2 is 4, c1 is 10 and c2 is 5. Therefore, a1 value is 3, a2 is 4, 3 into 5 15 minus 4 into 10 is 40, which is equal to minus 25. Now, to find the value of x is equal to dx by d, which is equal to, we know the value of dx is 50 by d is 25, which is equal to 2, and y is equal to dy by d, which is equal to dy is minus 25 and d is 25, which is equal to minus 1. Here the value of x, therefore x is equal to 2 and y is equal to minus 1. In this way, we have found the value of the variable x and y, and we have solved the simultaneous equation with the help of the Cramer's rule. One more example we will explain. Here there are two simultaneous equations. 4x plus 3y minus 4 is equal to 0 and 6x is equal to 8 minus 5y. But these simultaneous equations we are going to solve with the help of the determinant method, that is the Cramer's rule. But the equations should be in the form of a1x plus b1y is equal to c, in this form. But these equations are not in this form. First of all, we will convert these equations in this form. Therefore, 4x plus 3y, which is equal to 4 as a first equation, and 6x plus 5y is equal to 8 as a second equation. Here minus 4 is towards the, that is a constant term, is towards the LHS. We have transformed it to the RHS. And here the y term is towards the RHS. Therefore, we have transferred it towards the LHS. Now, we have to find the value of D, which is equal to A1, A2, B1, B2. Here it is A1, it is A2. Here we will write here A1 is equal to 4, A2 is equal to 6, B1 is equal to 3, B2 is equal to 5, C1 is equal to 4 and C2 is equal to 8. We have to find this value comparing these general forms with these equations. Now, which is equal to determinant of A1 value is 4, A2 is 6, B1 is 3 and B2 is 5, which is equal to cross multiplication we have to do minus 4 into 5 minus 6 into 3, which is equal to 4 5s are 20 minus the 18, which is equal to 2. Dx is equal to dx, we have to cover x and c1 c2 b1 b2, which is equal to, what is the value of c1? It is 4, c2 is 8, b1 is 3 and b2 is 5, which is equal to find the value of this determinant, we have to cross multiply 4 into 5 minus 8 into 3. 4 into 5 20, 24, which is equal to minus 4. Now finding the value of dy, which is equal to a1 a2 and c1 c2. Here we should not change these rows and columns of this determinant. By changing this sequence, we will not get the accurate answer because the value will be changed. A1 is 4, A2 is 6, C1 is 4 and C2 is 8, which is equal to 4 into 8 minus 6 into 4, which is equal to 32 minus 24. Therefore, dy is equal to 32 minus 24, which is equal to 8. So, therefore, x is equal to, we know dx by d, which is equal to, the value of dx we know it is minus 4 and d it is 2, which is equal to minus 2, and y is equal to dy by d, which is equal to, dy is 8 and d is 2, which is equal to 4. Therefore, x is equal to minus 2 and y is equal to 4. We have found the value of these variables x and y by the method Cramer's rule. Friends, today we have learned the determinant method. This method is used to solve the simultaneous equations which are in the form a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. If the given equations are not in this form, we have to convert in this form and we have to solve the further steps. In this way, we can solve the simultaneous equations with the help of the Cramer's rule.